Alright, time for another new filament. So this is from Eryone. Not sure how to pronounce that, but that's how I'm going to pronounce it. So I've used their filament before. Marble. So this is a really cool marble color. It's got little black flecks in it. And so I used that to make these Sabacc dealer tokens. This is a Star Wars poker game called Sabacc. And there's a link to the my Etsy store in the description, so you can see this in person. So this has got a steel weight in it to make it heavier so it doesn't tip over, and this shows who the dealer is. But anyway, so that I wanted to get a marble. It's supposed to be stone, so I used a really interesting technique to get this as a rough surface. But this Eryone filament worked out great. So I have a new project I'm working on, and so they seem to have the best filament for that project. Now I considered, for this new project, I considered using this silk red, which is from CC3D. So I've been using this for another Star Wars project, making these coins. So this silk red is the center of this coin. These are also available on my Etsy store. And these showed up in Solo, a Star Wars store, when they were playing Sabacc to win the Millennium Falcon. So that's fun. So I considered using this for this project, but I thought it was too shiny for what I wanted. So I'll show you what kind I got. And I wanted something a little darker. I wanted like a blood red was what I was looking for. So you can see there's quite a contrast here between the shiny. Now as a plus, this has a, it's called Galaxy Red because it has a silver sparkles in it. So that's going to work out even better for my project. So let's open this up. And it's got a really great vacuum, so you can see how far in this plastic is sucked in here. That means there's a really good vacuum. And it's got a desiccant pack inside. So we'll cut this open. Get a closer look at it. I have to hold my breath when I do these inside because there's some fumes. They're just accumulated inside the plastic. So desiccant pack, we'll save that, put it in our dry box as extra buffer. And so now you can get a better look at this blood red Galaxy filament and compare it to this. See, this is a lot, I would say it has more pink in it or white, and this is a lot darker. So this is going to work out great for our project. So at the end, I'll do our usual tests on this and do a fun print, but then at the end I'm going to actually show you what I'm going to make out of this for my Star Wars store on Etsy. So that's our start. So we'll weigh this and see if we got what we paid for. Okay, so this is a 1 kilogram reel, and let's put this on grams. And we have 1,209 grams, so that's I'm sure this reel doesn't weigh more than 200 grams. So I don't have one of these reels, empty reels yet. Once I finish this off, I'll say this is an empty reel. This is slightly more infrastructure in it, some more spokes. That'll be close. But I thought I'll use this CC3D reel as a that weighs 153 grams. So yeah, so we're definitely over 1 kilogram with this reel, so that's good. It seems nicely. It's got a little bit of waviness in the winding here, but I haven't really. As long as you keep control of the end of this filament and don't let it just go where it wants to go and get underneath some other wraps, then I've never had any problems with any filaments from any major manufacturer anyway. Okay, so we'll go ahead and do our pointy temperature tower like we usually do, and see what we can print this at. We're going to load our reel on the side loader as usual for the 1 kilograms. Now for these Eryone reels, the spacer fits inside this side for some reason. I don't know why they have this side flush and this side not flush. I'm not sure what the theory is on that. In any case, so that causes too much friction. So what I do is I put this piece of cardboard like this, and then it doesn't have that problem. I did find a new side loader solution I'm going to be working on in the next a few weeks or a month, or maybe a month. Depends on how much free time I have for my regular printing. But I did find a better solution that's going to make this a lot simpler to use and hopefully work better. Because I did have one particular filament break when it was a full reel, and I'm not sure what the particular print was. I don't remember, but I did have the filament break because it was too much friction. So I ended up using some paraffin on the inside of the reel and on the axle here to reduce the friction. So with the new side loader, that shouldn't have that problem. So I'll be showing you that when I have time to print it. So anyway, so just load it up as usual, and we'll start our pointing temperature tower, and I'll switch over to the time lapse. All right, so here's our temperature tower like usual. So we saved it at the new file with the name of the filament. And we're going from 210 to 230. We've been printing most of our PLA at 225. So I'm expecting that to be what we're going to use, but we'll see. Every film is slightly different, but it's been pretty consistent across multiple manufacturers. So, and it's a lot easier if I'm always at the same temperature. I mean, the filament will print at different temperatures, and there's not that much difference. I see people saying, I'm using 222 for the first layer and 219 for the layers after that. I don't think it's that precise. I'm just, that's my opinion. Anyway, so we're going to put the bed temperature at 40. We've been printing all of our PLA at 40 bed temperature, and that's got good adhesion without making it too hard to get off. So a link to this OpenSCAD file is in the description, and OpenSCAD is free, so you can download it. And we'll see how this turns out. Oh yeah, so we have to render it. Yeah. So that creates a G-code file, and then or an STL file, and then we save it. Again, with the name that we like to use. So, all right, there we go. So we can download that into OpenSCAD. I mean, Simplify 3D, and then print it out. I'll go over that next. All right, so we imported our STL file from OpenSCAD into Simplify 3D. I'll just go over that quickly again. So you go import, and then you find the STL file you want to import, and then you just open it, and it'll plop it in there for you. I'll go ahead and do that. And it just plops it on the bed, which is nice. A little bounce. So someone had some fun writing that part of the program where it bounces when it hits the bed. So I like that, since I'm a programmer. All right, and then the tricky part now is we need to get the different temperatures for the different layers. So bed temperature 40, and then the different layers. So layer 1 is our base. We're going to be printing at 230 and up through the end of this bridge here. And then at layer 18, that's actually when this bridge starts. Yeah. Then at layer 53 is when the next bridge starts, this base here. So that's 225, then 220, and down to 210. So this is super easy to set up with Simplify 3D. That's one of the reasons I use it for all my printing, pretty much. Because you can do different things at different layers really easily. It's not tricky at all. So, all right, so that's that, and we'll see how it prints out, and then we'll decide what to do for next. Turned out. So we bring it up here. Had a successful print, no blobbing or filament issues, and the color looks great. So this is going to work out good for our project. So we'll get this off. I mentioned it in the video about printing this. So we're printing this with a 40-degree bed temperature. All the PLA I've been printing lately, I've been using 40 degrees, and see, the bottom looks super clean, no problem with adhesion. Now if we look at the Seeing a little bit of sagging at 225 and maybe 230, so it looks like 220 printed the best. The pointer is fine. Looks like 220 is better. So let's check the back here. I think we'll print at 220 and 40-degree bed temperature. I've been printing PLA at 225, but we'll have to see. We'll try 220 and see if the adhesion is good. If it is, we'll stick with that. Otherwise, we'll go to 225. It's worth going through that to make sure. Because if your temperature is too low, you won't get good layer adhesion. I found that out the hard way. Okay, I have some problems at 220, although, so this is obviously some layer problems. I think the main part of it was that this thing came off the reel, it got caught down in here, like that, and it got all constricted. So there's a massive amount of friction to get it off of there. So that was probably what was going on here, most likely, but in any case, since I'm starting over, I decided to print at 225. I don't do a lot of bridging with what I'm printing, so I'm not that worried about sagging. So this is printed at 225, and it seems super strong, which is great. Let's get it off of here. Alright, let's check our bed adhesion. Bed adhesion is perfect, nice and solid, but it came off easily. So look at that bottom, perfect. That's a perfect bottom. And if we flex it this way, it's super strong. And let's check this lettering out. Got a little blob over here. Not sure what happened with that. The letters themselves look fine. I'm not sure what happened with this little blob over here. And these inset letters look great. So, alright, so we're going to put this at 225, and fan speed is 100 after the first layer. Alright, so the next thing we're going to do is CaliCat. So here's CaliCat. This is printed in the silk red that I showed you earlier, and here's the blood red color for this one with the sparkly stuff in it. So it's be interesting to compare them when they're done, and I expect this to look very spectacular in the CaliCat and my final project, which I'll show you at the end when I'm all done. Alright, we'll go to the time lapse for CaliCat. Okay, CaliCat is done. As usual, there's a string from the last spot over to the extruder. Not worried about that. Let's see how it turned out. Good bed adhesion. Tail is strong, so we get good layer adhesion. I can't quite bend this. There is one string from the tail back to the body, but that's very minimal. So here's the CaliCat we did. Oh, where are you? Here's the CaliCat we did for silk red, and here's the CaliCat we did for blood red, or galaxy red is what they call it, but it's a blood red with sparkly stuff in it. I think it's turned out great. It's gonna be the perfect color for my project, and I'm really excited about getting this going. So CaliCat's happy, I'm happy, everybody's happy. So again, after this, when I get all done, I'll show you what the new thing I made. It'll be available on my Etsy store with my other stuff. Oh yeah, CaliCat wants to tell you that again, the final temperature for my printer, my situation, it's about 68 degrees in the garage here, was 225 extruder, 40 degrees C bed temperature, 100% fan, or 0 fan on the first level, 100% fan on all the other levels. So that's my final parameters for printing with this filament. Yay! If you like this video, please give it a thumbs up. Post a comment if you have any questions or ideas, and I'll try to respond. That's all for now, but more videos are coming, and if you want to see them, please subscribe to my channel and turn on the notification icon if you don't want to miss one. This is Beta Cygni signing out, and keep looking up.